Hello everyone, hopefully you all be doing well. Well, today's topic is logic gates and circuits. It's a very important topic, and if you can understand it properly, then you can easily score good grades in the paper 2 as well. So let's start with the basic concept. What is a logic gate? Okay, as it's mentioned over here, logic gates are the basic components that make up a circuit. These circuits are used in almost every computer system. Okay, so basically, how does the logic gate work? It takes two binary inputs and it apply the Boolean operation, and then it gives you a output as a binary result. So moving forward, it's very important. If you have to remember this. True means one, and in other words, you can say on, yes, positive. These all are the values that can be taken for one. And for false, we take binary value of 0, and that value can be considered as off, no, or negative. So that's really important because it helps you in your past paper questions. So basic logic operators are AND, that is represented by a dot, or that's like a plus with a plus sign, and not is just simply represented by a bar, but it just simply flips the value. Okay. So there's a one practical example that you can consider. It simply states that let's say you have decided that you will like to treat yourself a good meal if you have money. Okay, so you also decided that you do that. So even when you don't have money and you are having a really bad. So if you have to express this in the form of a Boolean operator, how you can do that? You can combine it as basically in this way. You can say that if you have money, which means it's a true thing, you can have a good meal. But if you do not have a money, then you can't have a true meal, good meal. So that's a false. Okay. On the other hand, if you are having a bad day, then again you can have a good meal. But if you are not having a bad day, then you don't have to take a good meal. Okay. So if you convert this into the form of a logic expression, then it works in such a way. It simply says that you have money. So basically you're going to produce one, or you're going to produce two over here. So you are trying to produce one over here or a good meal over here in this particular scenario. So what you're going to go with, either you will have money, okay, then you can have a one, a true, or a good meal. Okay, or either you do not have a money but you are having a bad day, then you can have a good meal. So that's how it works in a normal life. Okay, there's another example given, but let's move on from this one. We have basically the types of the logic gate. Okay, so we have got 6 type of basic logic gates. Basically, in the past paper questions, you have to understand, you have to identify what kind of logic gate is given, and how does it work. More like what does it do. Okay, if you can understand that I can guarantee you can easily score good grades in the paper. And by the end of this video, if you follow this along, then hopefully you will get a better understanding of all this. Okay, so let's start with the first one that's given as a NOT gate. NOT gate just takes one input. Okay, it's like over here it's taken as 1, and it just simply flips it. It will give you a 0, or either it will take a 0 and it will give you a 1 in this scenario. Okay, so the NOT gate takes a single input and produces the opposite of that input signal as an output. Okay, so you have to understand 4 basic things regarding any gate. It's a basic symbol. Okay, how does it make, how does it look like? Okay, NOT gate is look like a triangle and with a circle at the end. Okay, then it's truth table. As we have seen, it only takes one input, so it will be like 0 and a 1. So 0 will produce us a 1 and 1 will produce us a 0 over here. For a logic notation, it will now simply be written as not a is any name of the any name that you have taken for it. Okay, and for the Boolean algebra, a bar is used to represent it. Okay, so not a will be presented as like a bar on the top of a, not b, not c. You can just simply put a bar on the top of that. Then we have got a AND gate. AND gate considers it takes 2 inputs, 1 and 0. Okay, so either it can 1 0 or either it can take 0 1. So that's the same thing, but at the end it will produces a 0 over here. Right now it producing 0 over here. So the concept over here is it takes 2 inputs and it produces 1 output. Okay, And also if both inputs are 1, okay, then the output will be a 1, otherwise it will always be a 0. So in order to get a positive answer, in order to get a 1, you have to make the both the inputs as 1 or positive or true, then you will get a true as your answer. Okay, again the fourth thing for this gate as well, the symbol, it is normally represented by a D type symbol. Okay, and then there's like a truth table goes with like there are like two zeros, two one, because now there are like two inputs. Okay, so with all the possible variation it's given over here. So 0 0 and 1 1 and 0 1 and 0 1, so these that cover all the possible variations. And again, for whenever any one of them is 0, then it will still produce a 0, but both of them have to be true in order to produce a true over here. Okay, and again its logic notation is simple: A and B, and it is represented by a dot. So A dot B is Boolean algebra form. Okay, then we have got a NOT gate. NOT gate is represented by this symbol. Okay, that will look like more like a fish, little bit. And then what does it do? It simply, it also takes two inputs. It produces one output. Okay, but for this one, it works in such a way: if either or both of the input is 1, it will produce an output of a 1. Okay, so I can simply say that like even when any of the condition is true, then it will give you a answer as a true. Okay, so again its symbol, then it's like table, and in the table you will see it's like 0 0 is like produces 0, but all the other outputs are produced as 1, because one of them is 1 in all, either 1 or both of the 1 are 1, that's why it's producing a 1. Okay, again its logic notation consists of a or, and it's a Boolean algebra form. It is represented by a plus sign, so that's how it works on. Okay, then we have got a NAND gate. Now we are combining the gates together. It's basically a AND gate combined with a NOT gate. Okay, so first of all you will apply the AND on the values, and then you will apply the NOT on the final result. That's how you will get your answer. In this particular over here, slide over here, what we can see over here is there's like two zeros. It will produce a 0 because it's an AND gate. 0 1, it will again produce a 0. 1 0, it will again produce a 0 because it's an AND gate. But at the end, if you will move on further, it will give you a, but now you have to, it's a NAND, so you have to apply NOT on it as well. So 0 will become 1, 1 will be 0 will become 1, 0 will become 1, and 1 will become a 0. So it will simply flips it, and that's how you'll get your final answer. So its final table will look something like this. And again, its logic notation is NAND, and it's represented by a dot for and a bar in order to represent the NOT on it. Okay, same way you can combine the OR and the NOT gate together. Okay, then you can apply the NOT OR first, and then you can apply the NOT. Again, 0 0 will produce a 0, 0 1 will produce a 1, any of the 1 will produce a 1 over here, and then you will flip it. So that's how it will give you this, and its a final table will look something like this, and that's how that's your final table. And then you have to go with like a logic notation x a nor b. Okay, nor, again not for the not and or for the or, so its logic notation becomes nor. And for the Boolean algebra form, it's like a plus for the or and a bar for the not. So that's how you get your Boolean algebra form. At the end, we have got the sixth gate, that's called a XOR gate or exclusive OR. Okay, it works in such a way, it's like the very much similar, its shape is very much similar to the OR gate, but with a one more bracket over here in the starting. Okay, so the output X is when either but not both of the A or B are inputs is 1. So in simple terms, if you can say it, if both the inputs are similar to each other, like 1 1 or 0 0, it will produce a 0. But if it's different from each other, then they will produce a 1. Okay, so over here it's given very clearly 0 0 and 1 1 are producing 0 and 0. But if the inputs are different, then it's producing a 1. It's a logic notation simple XOR, and its symbol is given over here in this form, a plus sign in a circle. Okay, now we can combine, that's the same thing, we have combined gates together, OR and NOT gate. Okay, it will give us the answers. Okay, so we can combine even more gates together. Okay, and it can be presented over here. The symbol was shown over there, but if you make it a circuit diagram, it can work like this. First of all, you are going with OR, and it's giving you an output as a P. Then there's a C input as well, and then you are taking its Q as an output. Okay, now you're combining P and Q, and you're producing a applying AND gate on them again, and then you're getting a final result. So it's called as a two-level logic circuit. Okay, so you can see yeah, you have to remember one thing over here that's very important. If they are like only two inputs, okay, then it goes like this: 2 power 2, it will produces, there are only 4 possible variations. Okay, but if they are like 3 inputs, then they're like 2 power 3 is 8, so there are like 8 possible variations that you have to remember. They're very easy to remember, like really very easy. If it's 2, then 0 0 1 1 0 1 0 1. But if it's 3, then 4 zeros, 4 1, 2 zeros, 2 1, and 0 1. So there's like a sequence that you can remember in this way. Okay. For this particular example, you can understand that like the first of all is doing an OR on A and B. So A and B or 0 0 will produce a 0 again. Whichever have got both the ones, it will only produce 1. So this one and this one is producing 1 1, and this one also have got a 1. If either one of them is a 1, then it will produce a 1. So this one have a 1, so it will produce 1 to have 1. Otherwise all of them, these two have got, none of them is 1, that's why it produces a 0. Okay, so now for the C1, it's simply saying it's the opposite of the Q. Okay, it's a NOT gate, so it will just simply flip it. So 0 will become 1, 1 will become 0, 0 will become 1. So it's just simply flipping it out. Okay, now at the end they're applying the AND gate. For the AND gate, we know what we have to do. We have to see for the P and Q now. We have to see if both of them are 1, then it will produce 1, otherwise it will produce a 0. So 0 1 will produce a 0, 0 0 automatically produce a 0, but 1 1 will produce a 1. Again, there's coming 1 1 over here to produce a 1, and both are true, and then it will also give you a true over here as well. Okay, so far we have studied this much, and that's the basic understanding of the logic gates. And in our next video we will go with the questions that will go on, that comes in the past paper. There are basically 5 types of the questions that comes in the past paper. We will study them one by one, and if you have any queries or if you have any questions, you can ask me. I will try to answer to my best of my capabilities, and see you in the next time. Thank you very much for your time.